Welcome to my video on scale drawings. So in the previous topics that we've discussed in this unit, we've looked at ratios, which is a comparison of two numbers. We've looked at proportions, which is two equal ratios. And now we're going to look at scale drawings and how proportions are used to solve them. So what exactly is a scale drawing? I'm sure you've seen many examples of scale drawings before, you just didn't know what they were. So a scale drawing is a two-dimensional drawing that accurately represents real-life objects of larger size. The scale of the drawing is the ratio of the size of the map or drawing to the actual size of the object. So, of course, a map is a scale drawing. A floor plan for a house would be an example of a scale drawing, or a floor plan for a school, or a floor plan for a building. These are all examples of scale drawings. When they create an action figure, they also use a scale drawing of the real size of the person or hero or actor. So scale drawing takes something that would be too large to fit on a piece of paper and shrinks it down into size. Now, obviously we can't draw a map of the US, so we have to use a scale drawing so that we can fit it on one piece of paper. Okay, so examples of scale drawings. In a scale drawing or model, all the dimensions of the actual object are enlarged or reduced proportionally by a scale factor. They are mathematically similar, same shape, but different size. So now we're going to look at some examples of different scales here. Okay, we could have 1:20. So this would mean 1 unit on a map or drawing is 20 units. We could also have 1 inch: 1 kilometer, which means 1 inch on a map or a drawing is 1 kilometer in real life. And we also have 1/4 of an inch equals 1 foot. So this would mean 1/4 of an inch on a map or drawing is 1 foot in real life. So finding distance using scale drawings. Now, this is where you're going to have to, I think your note sheet is a little messed up here, so you're going to have to write in map here. And I think your blank is missing, so go ahead and draw the line in here. So a map is a scale drawing in, you're going to have to cross out this part here, and we're going to write in which the actual distance is reduced. So underline here and fill in the word reduced. For whatever reason, it didn't print properly on your note sheet. Okay, now let's look at some examples. So we have example 1, finding the actual distance. So it says, on a map, the scale is 1 inch equals 50 kilometers. So let's underline that. The distance from Stanton to Virginia Beach on a map is 3.5 inches. Underline 3.5 inches. What is the actual distance from Stanton to Virginia Beach? Set up a proportion with the map scale guiding you. So underline what is the actual distance. Now, if you look at our numbers, if any of them are fractions, we've got to convert them to decimals. So I see 3.5, and what's 3.5 as a decimal? Hopefully you said 3.5. Now, what I like to do when I set up a proportion is I like to take the scale and make a ratio out of the scale. So I write 1 inch over 50 kilometers. Now, because I wrote inches over kilometers, over here I need to write inches over kilometers. So look at the piece of information that they gave me. It says 3.5 inches. So would I put the inches on the top or the bottom? Hopefully you said top. And now I got inches over kilometers, inches over x, and x is going to represent the kilometers. So when I label this problem, my answer, I'm going to write kilometers. So 1 times x is x. So I can put that 1 in disguise. I don't need to actually write the 1. And then 50 times 3.5 or 3.5 is 175 kilometers. Okay, circle your answer. And we have just solved a scale drawing question. Okay. Now remember, when you're doing these, write your scale as a ratio first. Okay. Moving on to number 2. Now we have to look at this, read the problem, and then look at the map to pull off some information. So it says on the map below, the distance from Portland to Olympia is 1 7/8 inches. What is the actual distance? Okay, so I have to look at the scale on the map and use that to figure out how many miles 1 7/8 inches is. So let's underline what is the actual distance. So if I look down here, I see 3/8 inch is 25 miles. So 3/8 is a fraction, so we need to convert it to a decimal. And hopefully you got 0.375 inches, and I'm going to use the colon, 25 miles. Okay, so now the scale is set for the proportion. Now we've got to change this to a decimal. So we have 1 7/8 inches. So this would be 1 875 thousandths. Okay, now let's set up the proportion. So write a ratio for your scale. So I'm going to write inches over miles. So we're going to write 0 and 375 thousandths over 25 miles. And I forgot to write the inches. Now, when you're doing these problems on your own, if you can do it without writing the inches and the miles, that's great. But for our note purposes, I want you to write inches and miles so you can get in the habit of seeing that inches over miles. And then on the other side, we got to make it look exactly the same. So now on the right side, I have to make sure it says inches over miles. So I have 1.875 inches. So I'm going to put that one on the top. And I don't know what the actual distance is, so I'm going to put X on the bottom. So now my label is going to be miles because I have inches over miles, inches over miles. So now we're going to use the cross product. So 0.375 times X is 0.375X. And then 25 times 1 875 thousandths is 46 875 thousandths. Now the opposite of multiplication is division, so I'm going to multiply both sides by 375 thousandths. And then 375 thousandths divided by 375 thousandths is a 1 in disguise. And when I divide these two numbers, I get 125 miles. Okay. And that's because it takes 5 of these, okay, 5 of these to make 1 7/8 inches. So then 25 times 5 would be 125. But you probably didn't know that 5 of these made 1 7/8, so that's why we use a proportion to help make it a little bit easier. Okay, look at number 3. Find the size of the model. So a building is shown with its dimensions. What should the height of the model be with a scale of 2 inches is 5 feet? So underline that. If the height of the building is 40 feet, find the height of the model using a proportion. Okay, so the first step is to see, first of all, if we have any fractions, and we don't. So now we're going to find our scale and write a ratio. So 2 inches over 5 feet equals, now we have 40 feet, and we want to find the height of the model. So the height of the model is going to be inches, because 2 inches equals 5 feet. So the height of the model is the inches. So we're going to put 40 feet on the bottom to match the feet on this side, and we're looking for the actual height of the model. So this is x, and our label is going to be inches. So we have inches over feet, inches over feet. Now, cross product, 5 times x is 5x, and 2 times 40 is 80. The opposite of multiplication is division. 5 divided by 5 is a 1 in disguise, and 80 divided by 5 is 16 inches. Okay, one last problem, and then that concludes our notes. So example number 4 here says converting metric and customary units using a chart. So it said if a man weighs 85 and 5/10 kilograms, how many pounds does he weigh? Okay, so we want to know how many pounds a man weighs if he weighs 85.5 kilograms. So we need to know the ratio of the two measurements. So if we look at our chart here and we find weight, we find 1 pound equals 45 hundredths of a kilogram. So circle this. There is our scale. So we're going to write a ratio. So 1 pound over 45 hundredths kilograms. And notice I put pounds over kilograms. So over here I need to put pounds over kilograms. And so we have 85.5 kilograms. So we're going to put that on the bottom, because we want to know how many pounds. And I don't know how many pounds, so we're going to put X on top. Now we're going to cross product. And 45 hundredths kilograms times X is 45 hundredths X. And 1 times 85 and 5/10 is 85 and 5/10. Now the opposite of multiplication is division. So we're going to divide both sides by 45 hundredths. And 45 hundredths divided by 45 hundredths is a 1 in disguise. And 85 and 5/10 divided by 45 hundredths is 190. And our label is pounds. So notice we didn't do anything differently than we've done before in proportions. We kept it consistent. If we did pounds over kilograms, on the other side we did pounds over kilograms. The only difference here was the topic that we were talking about, scale drawings. And remember, scale drawing is used to enlarge or reduce the size of something. That concludes our notes. Have a great day.